In this video, we'll talk about adding and subtracting in scientific notation. We'll talk through the PowerPoint that is posted in Google Classroom. When you add or subtract in scientific notation, the exponents of 10 must be the same. So if you're given a problem and the exponents are already the same, you just follow these two steps. You would add or subtract the bases, and then step 2, you would keep the power of 10 the same. And remember, I want you guys to round the final base to the nearest tenth so that we can keep from having to write all the digits after the decimal point. If you're given a problem and the exponents are different, you have to, step 1, adjust. You have to adjust the decimal point to get powers of 10 to be the same. And to adjust the decimal, remember, we use the acronym LARS. If you move the decimal left, you add to the exponent. If you move the decimal right, you subtract from the exponent. Once you adjust the decimal so that the powers of 10 are the same, then you follow these two same steps. You would then add or subtract the bases and keep the power of 10. Now in this video, we're only going to do a couple examples that have to do with exponents being the same on the power of 10. All right. In the next video that I'll post, we'll do examples on exponents that are different. So here are the general formulas for adding and subtracting in scientific notation. You need to copy these down onto your handout. So here's the addition one. If you have a number n times 10 to the power of x plus a number m times 10 to the power of x, this is how you would go about solving it. Since the exponents are the same, we need to add or subtract the bases. So the exponent is x, exponent is x. So that tells me I can add these bases together. So I add n plus m. That's represented right there. N, the base n, plus the base m. That would be step 1. Step 2 would be to keep the power of 10. Since the power of 10 is 10 to the power of x, right? This is the power of 10. Those are the same, and so I keep it right there. Okay? So once I add the base n plus m times 10 to the power of x, that would be my answer. Now for subtraction, it's very similar. If you have a number n times 10 to the power of y, and you're subtracting a number m times 10 to the power of y, you just simply subtract the bases. Since you're subtracting, you subtract n minus m as represented right there. Since your bases are the same, both bases are 10 to the power of y, 10 to the power of y, 10 to the power of y, you keep it the same. Once you subtract n minus m, you multiply that times 10 to the power of y, and that would be your answer. So again, get those general formulas onto your handout. Finally, we'll end with 2 examples, one addition and one subtraction. Now in both of these examples, you're going to notice that the powers of 10 are the same. So we can go ahead and add and subtract the bases and then keep the power of 10. So in example number 1, we have 2.56 times 10 to the power of 3 plus 6.964 times 10 to the power of 3. So step 1, I'm going to add the bases together. I'm going to add 2.56 plus 6.964. So 2.56 plus 6.964. Okay, I'm simply adding the bases together. If you add those together, you will get 9.524. I add the bases, and then I'm going to keep the power of 10. So 10 to the power of 3, 10 to the power of 3. I keep that base, or sorry, I keep that power of 10. So 10 to the power of 3. All right. So technically, this is the specific answer, 9.54 times 10 to the power of 3. But again, I want you to round this final base number to the nearest tenth. Okay, so I draw my little squiggly. I'm looking at that 2. That 2 in the hundredths place tells me to stay the same. I do not round up. So 9.5. 9.5 is my final base number. And this stays the same, times 10 to the power of 3. That'd be my answer. Example number 2, here's a subtraction one. My powers of 10 are the same. This is 10 to the 5th. That's 10 to the 5th. So I can go ahead and subtract my bases. 9.49 minus this base, 4.863. When I subtract those bases, this minus this, I will get 4.627. And then my power of 10 stays the same. 10 to the power of 5, 10 to the power of 5. That stays the same. This is technically the answer. That's the specific answer. Again, I want you to round the final base number to the nearest tenth. So I'm rounding it to the nearest tenth. I look at the hundredths place. There's a 2 in the hundredths place. That tells me to keep this 4.6 the same. So 4.6 is my final base number. The power of 10 stays the same, times 10 to the power of 5. And that's my answer.